Hey math fans, we're on section 2.1.2. Let's get started. Today we're going to continue to look at quadratic equations. There's three forms that we're going to be looking at for the majority of the time. They are called standard form, vertex form, and factored form. This is their basic structure. Standard form has ax squared plus bx plus c. And you can find the vertex rather quickly by going negative b over 2a. That will give you the x value for the vertex, and then you can resubstitute back in from there. But what's an easier way to even get that vertex is to use what's called vertex form. Vertex form has parentheses x minus h squared, and it just has that one set of parentheses with the value of k that follows. Now, intercept form has two parentheses, and that's how you can kind of keep track of these two different forms. As I previously mentioned, if you have standard form, easiest way to find the vertex is to use that formula x equals negative b over 2a. When you graph a quadratic, remember it creates a parabola. A parabola looks like a u and a v combined. And if the a value, which is the first term in a quadratic in standard form, is positive, if that a value is positive, it will open upward. If a is negative, it'll open downward. Now, using vertex form, you also have an a out front, which the same rules apply, and we'll review that in a second. But the great thing about vertex form is that it has this h and k, which is the vertex, and it kind of is already staring at you in the face. There's one little problem though. There is a negative in the formula. And so we have to be careful when we're actually removing that h. So what we're going to end up doing is setting the parentheses equal to 0 and really solving for x. That will be the actual true value of h. So here it is again, the vertex form of parabola. The vertex is h comma k. A couple other things about a. So if a is positive, it'll open up. If a is negative, it'll open in a downward direction. If a is greater than 1, like 2, 3, 4, anything greater than 1, 100, it will make the parabola skinnier. It'll appear skinnier. And if it's a fraction, like something less than 1 but greater than 0, like 1/2 or 1/4, it will actually make the parabola wider. Now, factored form doesn't give you the vertex, it gives you the x-intercepts, which are also known as the solutions, or sometimes they're called the zeros or roots. If you want to find the vertex pretty quickly, you could average the two x-intercepts, because when you're dealing with a parabola, the vertex will be halfway between those two x-intercepts. Again, this formula has negatives as well, so we need to set both of those parentheses equal to 0 when trying to figure out what are those x-intercepts. Here's an example of a parabola, and it has the equation written in blue at the bottom, x plus 3 times x minus 2. Now the solutions, the x-intercepts, the roots, the zeros, they all mean the same thing. We have an x-intercept here at negative 3. And notice that it says x plus 3 in parentheses. Well, if you were to set that equal to 0, you would solve for x and get negative 3. So that's how you solve correctly for the x-intercept there. And then, of course, positive 2 is your other x-intercept. Here's another example. Notice that a is negative in this particular scenario. So negative 2 creates a downward parabola. And notice that x minus 3, well, what's the x-intercept? It will be x plus 3 if you solve for x and set the parentheses equal to 0. And then it says x plus 4, so that means the x-intercept is negative 4, 0. So what's the difference between factored form and vertex form? Well, factored form has two sets of parentheses that give away the zeros, or the x-intercepts. In this case, they're called m and n. But vertex form gives you the vertex right away. It gives you h and k. Again, in both of these scenarios, just be very careful where that negative appears. Here's some common errors and misconceptions. Example 1. Suppose that the flight of a launched bottle rocket can be modeled by this particular function, where f of x measures the height vertically and x represents the horizontal distance. So how far did the bottle rocket travel? What's the maximum height? How far has the bottle rocket traveled horizontally when it reaches its maximum height, and graph the function? Well, the first thing I want to do is analyze the function they gave us, and it is written in factored form, which really tells us the x-intercepts. Remember, we're going to set these parentheses equal to 0, and so I'm going to get an x-intercept of +1 and +6. Also, the a value is negative, so it's opening in a downward direction. Now the question is, well, where is this rocket going to reach its maximum height? And how far has it flown horizontally when it's reached its maximum height? So in order to figure out that point, we need to find the vertex. In order to find the vertex using factored form, we take both of those x-intercepts and let's just average them, because the vertex is going to be in the middle. It's always in the middle of the parabola. So 6 plus 1 divided by 2 is going to be 3.5. So that means it's reached its maximum height after it's flown horizontally for 3.5 meters. But what is that maximum height going to be? How do we get that value? Well, we have the original equation, and so what we can do is we can substitute that value of 3.5, and it looks like we're going to have to do it twice here, in for x. So 3.5 minus 1 times 3.5 minus 6, and you get 6.25. So what does this vertex mean? This means after this rocket has flown horizontally a distance of 3.5 meters, it's reached a maximum height of 6.25 meters. You could also answer other questions like, how far has it traveled when it reaches that maximum height? How far has it traveled horizontally? And the answer is 2.5. And then it traveled another 2.5 to where it landed. As with any function, if you want to get specific points, what you do is you substitute values for x, so we get values for y, and you can graph the function. So after a little bit of number crunching, here are some points that are actually on the parabola, and that's what it will look like fully completed. Here's an example of a quadratic where it's written in standard form. It says identify the y-intercept, identify the vertex, and whether the function has a maximum or minimum. Before you even get started, we should probably take a look at what's the value for a. Well, a is +1, so it's going to open up. B is -8, and C is 12. And we're going to learn that C in standard form is always the y-intercept. And since this thing is opening in an upward direction, that means it's going to have a low point or a minimum. So what is the y-intercept? The y-intercept is going to be 0, 12. In other words, if I substitute in 0 for x, I'm going to get the value of 12 out. So at this point, it's either going to look like the graph on the left or the graph on the right. So how do I know which one it is? Because they both have a y-intercept of 12. Well, for that, you do need the vertex. And the formula you use for that is -b/2a. So remember, the opposite of a negative is positive. So that's going to be +8/2, which is +4, which means it will actually be the one on the right because the x value will be positive. So there's the graph there. We have the vertex at 4, but we don't know how low it goes. And the easy way to do that is to substitute 4 back into the original equation. So how do you find that minimum y value? Let's substitute 4 back in, and we get -4. So whenever you have the x value of the vertex, you can always get the y value by substituting it back into the original equation. So here's your final graph. You have a vertex at 4, -4, and you have a y-intercept of 0, 12. All right, one more example. Thanks for hanging in there. Here's a vertex form. Now, vertex form, remember, gives you the vertex, and be careful because we got to set those parentheses equal to 0, and then you get a positive 2 value, but the value of the outside, that negative 4, stays the same. This is a positive 3, so it's going to open up. That is not the y-intercept. A lot of people think that negative 4 is the y-intercept. That is the y value for the vertex. So to get the y-intercept, we're going to substitute 0 in for x. And once you do that, you get a value of 8. So the y-intercept is actually 8, much different than negative 4, right? And this is what the graph of that particular parabola looks like. You have a vertex of 2, comma, negative 4, which we got right away from the vertex form. But then we needed that y-intercept, which was 0, comma, 8. And you only get the y-intercept by substituting in 0 for x. And that's going to do it for this section. We'll see you in class.